Lesson 19. Choosing the state structure. 1. Introduction. Let's begin by understanding why structuring state correctly matters. When you design a component that manages its own state, the way you organize that state can make a huge difference. A well-structured state makes the component easy to update, easy to debug, and less prone to bugs. A poorly structured one, on the other hand, becomes a source of constant confusion. So, let's go through some key principles that will help you structure your state wisely. 2. Principles for structuring state. When you define state for a component, you face a few choices: how many state variables to use, what kind of data to store in them, and how to keep them consistent. Even though it's possible to make your code work with a bad structure, it will often lead to hidden complexity and bugs later on. To avoid that, there are several guiding principles. First, group related pieces of state together. If two or more variables always change at the same time, they probably belong in one shared state structure. Second, avoid contradictions in your state. If you design your state so that two variables could disagree with each other, you're inviting logical errors. Your state should only represent valid situations. Third, avoid redundant state. If a value can be calculated from existing state or props, don't store it separately. Redundant data leads to unnecessary synchronization work. Fourth, avoid duplication in state. If the same information is stored in multiple places, you'll need to keep it consistent manually, and it's very easy to forget one spot. Finally, avoid deeply nested state. The deeper your state structure is, the harder it becomes to update and maintain. A flatter design is almost always simpler to handle. All of these principles share a common goal: make updates safe, predictable, and easy. You can think of it like database normalization. Just as database engineers reduce redundancy to prevent inconsistency, we should simplify our state to reduce bugs. Or, as Einstein might have put it, make your state as simple as possible, but no simpler. 3. Group-related state. Sometimes you may wonder whether to keep two variables separate or merge them into one. The key question is, do they always change together? If they do, for example, two coordinates that always update simultaneously, then grouping them makes sense. By combining them into a single object or structure, you prevent situations where one updates but the other doesn't, keeping your component consistent. Another reason to group data is when you don't know in advance how many elements you'll need, such as in a form where users can add multiple custom fields. In those cases, arrays or objects often work better than several separate state variables. However, remember that when your state is stored in an object, updating one property usually requires you to preserve the others as well. If you forget to copy the rest of the data, you may unintentionally delete other parts of the state. 4. Avoid contradictions in state. Imagine a form that keeps track of whether a message is currently being sent and whether it has already been sent. If you store both of those as separate variables, there's a risk that they could both end up being true at the same time, which doesn't make sense logically. To avoid this, think in terms of a single status variable. That variable might take values such as typing, sending, or sent. This approach ensures that the component can only ever be in one valid state at a time. You can still use simple checks like, is it sending, or is it sent? But these would just be derived from the status, not stored independently. That way, there's no chance of them getting out of sync. 5. Avoid redundant state. Redundant state is any information that can be derived from other state variables or props. Let's take the example of a form with first name, last name, and full name. If you already have the first and last names, there's no need to store the full name separately. You can simply combine them when rendering. Why is that better? Because when you change either the first or last name, the full name will automatically update when the component re-renders. There's no risk of one being updated but not the other. So the rule here is simple. If you can compute something from existing state, don't store it separately. 6. Avoid duplication in state. Duplication happens when the same piece of data exists in more than one place. For example, imagine you have a list of snack items, and you also store one of them as the selected item. If that selected item is stored as a full copy of one of the objects in the list, then you're duplicating the same information. What's the danger? If the list changes, for example, if you edit the title of the snack, the selected item won't automatically reflect that change, because it's just a separate copy. A better approach is to store only the essential reference, for instance, the ID of the selected item. Then, whenever you need the full details, you look them up from the list. This eliminates duplication. Now, when you edit an item, the displayed selection automatically updates because both the list and the selected reference point to the same source of truth. 7. Avoid deeply nested state. Sometimes you might be tempted to represent your data as a deep tree of objects, for instance, a hierarchy of travel destinations with continents and countries nested within each other. This kind of deeply nested structure can quickly become painful to update. If you want to change something deep inside the tree, you have to carefully copy and rebuild every level of the hierarchy above it. That's a lot of repetitive code and a major source of errors. A good alternative is to flatten the state. Instead of nesting objects, you can store them in a dictionary or table-like structure, where each item is keyed by its ID. Each item then simply lists the IDs of its children, not the full objects themselves. This approach, sometimes called normalizing your state, makes updates much easier. When you remove or modify an item, you only need to update the relevant entries, rather than traversing and copying a whole nested structure. It's the same principle that databases use to avoid redundant data and complex update chains. You can still represent relationships between elements, but your updates remain straightforward and predictable. And if you ever find yourself struggling with nested updates, that's usually a sign that flattening the structure will simplify your life. 8. Recap. Let's summarize the main takeaways from these principles. When two pieces of state always update together, merge them into one. Avoid contradictory or impossible states. Use a single source of truth for status. Don't store what can be calculated. Remove duplication to keep your data in sync automatically. Never copy props into state unless you have a very specific reason. For selection patterns, store IDs or indexes, not the full objects. If your state becomes deeply nested and hard to update, consider flattening it. In short, structure your state so that it reflects the essential truth of your component, no more, no less. Keep it simple, consistent, and easy to update, and your components will remain clean, predictable, and a pleasure to work with.